This proof is number 2 on the trig identities review. And for this proof, if you look at the left side of it, you should think that there are two fractions that need to be combined through subtraction, and the only way that you can combine two fractions through subtraction is if they have the same denominator. So your first logical step here would be to get a common denominator. We're going to do this by multiplying the left fraction by secant x plus 1 over secant x plus 1, and the second fraction by secant x minus 1 over secant x minus 1. Or in other words, we're multiplying each fraction by a fancy form of 1 in order for them to have the same denominator. I have now shown that next step with both expressions being multiplied by their fancy form of 1 with my beautiful handwriting. So the next step would be to distribute both sets of fractions. So if you look at the first set of fractions, you're going to multiply in, or really kind of think about it as backwards distributing, the cosine x by plus 1 and the cosine x by secant x. And we're going to do the same thing on the other side, just to be careful that that minus in the middle is kind of troublesome for some people. We're going to have to remember to distribute that in later, but for now we can just take care of multiplying in the cosine x with the minus 1 and the secant x. So I'm going to show that in the next step. Okay, so what I've done here is distributed it out and just wrote the top as one big numerator, and then in the denominator, since both set of fractions have a secant x plus 1 and a secant x minus 1, I just went ahead and put those together here in the denominator. In my next step, I'm going to do two different things. I'm going to, first of all, take this negative that's up top in the numerator and distribute it to both terms here in parentheses. So it's going to change both of those signs. And then in the denominator, I'm going to go ahead and multiply out, distribute these two. In other words, you're going to FOIL them together. And hopefully it'll give us one of the Pythagorean identities that we can use. Now if you notice, I'm not doing anything to the right side of this expression because when you do a trig proof, you're only allowed to work on one side of the equation to verify that it equals the other side of the equation. So I'm going to go ahead and do that multiplication now. Alright, so I'm on a new page now. I've distributed the negative up top, and then in the denominator I've distributed the two binomials together. And if you notice, you have this positive secant x cosine x, and you have this negative secant x cosine x, which is great because they are going to cross each other out. And then you have these two cosine x's that are just hanging out. And since there's two of them, you can combine them to make it 2 cosine x. Alright, so these two are going to go away. Need to fix my pen. Alright, so when those two go away, and you have these 2 cosine x's, so you have 2 cosine x up top. Then in the denominator, if you look at your Pythagorean identities, which remember you need to know those by heart, on the bottom you have secant squared x minus 1, which is equivalent to tangent squared x, which is kind of fantastic because the other side of the verification is 2 cosine x over tangent squared x. And we're done. Hooray!